The quest for extraterrestrial life has propelled innumerable sci-fi stories and has even filled missions by NASA. Perhaps one of the most charming spots in this search is Europa, a moon of Jupiter which many accept could hold vital data. Bill Nye, the notable science fellow, is among those who advocate for additional investigation of Europa, accepting that this divine body may be vital to disentangling the secrets of life beyond Earth. NASA's Explorer 1 shuttle, sent off in 1977, made a momentous disclosure outside our nearby planet group. This revelation has drawn the attention of some of the brightest minds today, including Bill Nye. What Explorer 1 found was ionized gas particles, effectively conflicting and collaborating just past the heliosphere, the bubble-like region made by the solar wind. These readings gave critical insights into what conditions may be like beyond our planetary group. Could these be markers of extraterrestrial life? This inquiry has caught the imagination of researchers and space fans alike. Bill Nye has for quite some time been a leading figure in the quest for extraterrestrial life. His passion for the unknown is clear in his interviews and talks, where he frequently stresses the importance of space exploration. The discovery made by Explorer 1 has also fueled this enthusiasm, offering new information that could potentially answer the age-old question: are we alone in the universe? To understand why this discovery is so significant, it's essential to return to the beginning of space exploration and the events leading up to the launch of Explorer 1. In the mid-1970s, NASA had recently achieved a great accomplishment by sending humans to the moon. This success sparked broad excitement within the scientific community, and plans were soon in progress to explore much farther into space. NASA's next objective was to study the outer planets of the solar system. However, sending humans on such a mission was not yet feasible. The vast distances and the limitations of 1970s technology made it necessary to rely on robotic spacecraft for these ambitious investigations. At the time, the Cold War was in full swing, and the U.S. was in a fierce competition with the Soviet Union. This rivalry extended into space, where both countries were striving to demonstrate their technological superiority. The Soviets had made the first significant steps in space exploration, launching the first artificial satellite in 1957 and sending the first human, Yuri Gagarin, into space in 1961. However, the U.S. caught up with the Apollo 11 mission in 1969, landing astronauts Neil Armstrong and Buzz Aldrin on the moon. This triumph was a turning point in the space race. However, the U.S. knew it couldn't rest on its laurels. The competition with the Soviet Union continued to drive NASA's aspirations to maintain their lead in space exploration. NASA needed to go beyond the moon, and the new goal was to explore the outer planets. The agency began developing spacecraft capable of traveling deep into space. One of NASA's first efforts was the Pioneer 10 spacecraft, launched in 1972, which became the first to fly by Jupiter and send back pictures. Pioneer 11 followed the next year, also heading toward the outer planets. However, NASA needed a more advanced spacecraft that could capture detailed images and data from not just Jupiter, but also Saturn, Uranus, and Neptune. This led to the development of the Voyager program. The plan was ambitious: to use a rare planetary alignment known as the Grand Tour to slingshot the spacecraft from one planet to the next using gravitational forces. This alignment, happening only once every 156 years, would allow NASA to study all the outer planets in a single mission, saving both time and money. To achieve this, NASA built two Voyager spacecraft. Voyager 1 was designed to take a shorter path, visiting Jupiter and Saturn, while Voyager 2 would follow a longer trajectory to reach Uranus and Neptune. On August 20, 1977, Voyager 2 was launched, followed by Voyager 1 on September 5 of the same year. These twin spacecraft would go on to make some of the most surprising discoveries in the history of space exploration. Voyager 1 began capturing images of Jupiter on January 30, 1979. These images revealed details of the gas giant that had never been seen before, including its Great Red Spot, a massive storm that had been raging for centuries. But Voyager 1's mission didn't end there. After completing its flyby of Jupiter, the spacecraft continued on to Saturn, where it sent back even more remarkable data. The discoveries made by Voyager 1, especially its detection of ionized gas particles outside the solar system, have had a profound impact on our understanding of the universe. As the Voyager missions continue to send data from the farthest reaches of space, the search for extraterrestrial life remains as important as ever. Bill Nye and other scientists believe that exploring places like Europa, with its subsurface ocean, could yield the next major breakthrough. What we learn from these missions could forever change our understanding of life in the universe. Every 96 seconds, Voyager 1 captured images and combined them to create a colored stop-motion video. Using this technique, Voyager 1 was able to send back a film showing 10 rotations of the largest gas giant. By February 10th, Voyager 1 had moved into the planet's moon system, sending back footage of the moons orbiting the gas giant. It soon discovered a thin ring of dust and ice surrounding the planet that was invisible from a distance. This showed that Saturn was not the only planet surrounded by rings. The ring was less than 30 meters in diameter, and it astonished researchers how little they knew about this planet. By April 5th of that year, Voyager 1 had its closest encounter with a giant planet, separated by a mere 174,000 miles. During this close pass, the spacecraft encountered several of Jupiter's moons, including Io, Europa, Ganymede, and Callisto. The images it sent back provided invaluable insights into the strange worlds of these moons, some of which had little in common with our moon. These moons were later referred to as the Galilean moons, named after the astronomer Galileo Galilei, who discovered them in the 17th century using his telescope. One of the smaller moons observed by Voyager 1 was Amalthea, a reddish, irregularly shaped satellite with a bizarre surface structure. Images sent by the spacecraft showed that it was composed of ice and silicate materials. The surface appeared red due to the presence of organic material, and its oddly twisted surface indicated that it had experienced very little internal activity compared to the other moons. Io was found to be the most geologically active body in the solar system, with many active volcanoes and lava flows visible on its surface. These volcanic activities were triggered by tidal heating caused by Jupiter's immense gravity, making the moon appear more like a volcanic inferno than a moon. Europa was particularly striking for its smooth, icy surface, covering a vast expanse of water beneath. Many researchers believe that life could flourish beneath the ice, making the moon a prime candidate for extraterrestrial life. A few craters were found on the icy surface, showing past collisions with asteroids and smaller comets. What followed were images of arguably the largest moon in the solar system, Ganymede. This moon was so large that it surpassed the size of the planet Mercury. It was large enough to have its own magnetic field, and the images showed that its surface was primarily covered in rocks and ice. Ganymede's potentially complex geological history continues to amaze scientists to this day, and it likely contains a liquid core deep inside, responsible for its strong magnetic field. Another large moon observed by the spacecraft was Callisto, the second largest of Jupiter's moons. Its heavily cratered surface indicated a period of frequent impacts with asteroids, and it also showed an absence of geological activity. Like Europa, it has an ocean deep beneath its surface, making it another candidate for extraterrestrial life. 2 new moons were discovered by the spacecraft and named Thebe and Mimas. The images indicated that they were both small and irregularly shaped, much closer to the planet than the other satellites. It is interesting to note that the planet itself and the moons observed by the spacecraft were named after famous mythological figures. The giant planet was named after the well-known Greco-Roman god of thunder, and the moons were named after those who had close encounters with him. After the spacecraft's encounter with Jupiter, a course correction was made so it wouldn't spiral out of control like the natural satellites. This was done in preparation for its journey toward Saturn, about 6 months later. By October of that year, another course correction was made to prevent a possible collision with Titan, one of Saturn's moons. The encounter with Saturn was just as spectacular as the previous one with Jupiter, with the spacecraft discovering 5 new moons, a ring system with thousands of groups of particles, transient clouds made up of particles called spokes, and a new ring that couldn't be seen from a distance. It was also discovered that there were moons responsible for keeping Saturn's rings as defined as they are. It is likely because of these moons that the planet's rings look so pristine. In the coming weeks, Voyager 1 captured brilliant photos of Saturn's moons, including Titan, Mimas, Enceladus, Tethys, Dion, and Rhea. The photographs demonstrated that they were largely composed of ice, with possible oceans beneath them, increasing the possibilities of extraterrestrial life flourishing outside Earth. But those weren't the only discoveries that stunned the scientists at NASA. More specifically, the moon Mimas, a relatively small moon, had a unique feature that intrigued sci-fi fans for many years. This moon had a massive impact crater so large that it was given the name Herschel. What made it so interesting was that it made Mimas appear to be the Death Star from the famous sci-fi series Star Wars. This fascinating feature showed extremely low geological activity and a significant past impact with a large asteroid. Other moons observed by the spacecraft were mostly composed of ice, with a few notable characteristics distinguishing each of them. However, perhaps the most intriguing of the other moons seen by Voyager 1 was Titan, closely observed by the spacecraft on November 12 at a distance of less than 3,000 miles. The images revealed a thick atmosphere that completely hid the surface. The atmosphere was composed mostly of nitrogen, with the atmospheric pressure equal to that at sea level on Earth, but at a chilling 300 degrees Fahrenheit. Features on the moon suggested that it might be the only body in the solar system, apart from Earth, where liquid could exist on the surface. The chemical reactions needed for the formation of life appeared to be present on this moon, with strong indications of significant hydrocarbons required for life to emerge. The spacecraft's closest approach to Saturn was on November 12, at less than 8,000 miles from the planet. By 1989, all the planetary encounters were over for both spacecraft, as all four gas giants had been explored as planned. However, both spacecraft were still operational and were declared part of the Voyager interstellar mission, a program that officially began on January 1, 1990. The new goal was to travel farther than the outer planets of the solar system and, if possible, even beyond. The more specific objective was to gather data on the region of space dominated by Earth's magnetic and solar fields, as well as the interstellar medium. On February 17, 1998, Voyager 1 became the most distant human-made object in existence, surpassing Pioneer 10 at a distance of nearly 70 astronomical units. By September 2017, 45 years after launch, the spacecraft was still operating successfully, sending back data from its instruments to NASA's Deep Space Network. It was astonishing to researchers that the Vast Beam Telescope magnetometer still worked properly after more than 40 years of traveling through space. Now traveling into interstellar space, scientists hoped that something out there would receive the message we have sent out. Voyager 1 and Voyager 2 ventured farther from the Sun. Their missions took on new importance. Voyager 1 entered interstellar space in August 2012, marking humankind's first journey into this unfamiliar region. This achievement gave scientists a unique opportunity to study the conditions of space beyond the heliosphere, the protective bubble surrounding our solar system. Voyager 1's data has been instrumental in understanding the nature of cosmic rays, magnetic fields, and plasma interactions in interstellar space. Voyager 2, meanwhile, continued its mission to explore the outer edges of the solar system and eventually entered interstellar space in November 2018. Its trajectory provided important comparisons to Voyager 1's data, enhancing our understanding of the boundaries of the solar system. Both spacecraft carry a golden record containing sounds and images meant to represent the diversity of life and culture on Earth. This record is a message to any potential extraterrestrial civilizations, showing humankind's desire to connect with the universe. As the Voyagers continue their journey, they also contribute to the broader field of astronomy by observing phenomena such as the interstellar medium, the local interstellar cloud, and the interaction of the solar wind with the galactic environment. Their discoveries have provided insights into the structure of the heliosphere and the nature of the interstellar magnetic field. The data from both spacecraft is also critical for future interstellar missions. As technology advances, scientists and engineers are studying the Voyager's performance to develop new spacecraft capable of traveling much farther into space. This includes potential missions to explore nearby star systems or examine the limits of the Milky Way galaxy. The legacy of the Voyager missions lies not only in their immediate discoveries but also in their role as forerunners to humanity's deeper exploration of the universe.